for that matter, any other open source programming language. Nowadays, even you got a Kotlin also. Very good work is being done in the Kotlin also. So it depends what all you're comfortable with, and accordingly you can choose one of the programming language for carrying out your simulation work. So MQTT is a message queuing telemetry transport widely used protocol and sorry preferred protocol in the IoT
Just an
network.
interruption, sir. Just
Yeah,
interrupting you. Are you sharing slide? People, participants are saying
yeah, yeah,
slide
yeah,
is not
yeah,
visible.
yeah. I'm sure, sure, sure. Are the slides visible?
Yes, yes. Now it is visible, sir.
Okay, okay, okay. So it's a very popular protocol, the message queuing telemetry transport, commonly called as the MQTT or the Mosquito protocol. There are two protocols we widely use in the IoT network. One is a Mosquito, the MQTT protocol, and the other one is a COAP. We call it as a Constraint Application Protocol. So they are the two most widely used protocols. So today we'll discuss about the theory part of the MQTT as we'll see the Java-based simulation, how we can emulate the MQTT protocol. So there are certain predefined libraries which we need to download on our system. Uh, I will show you the demonstration of it, how to do it. And those of you who are comfortable with Java programming language, rather I will advise you to parallelly do it on your own system also, because it will not take that much amount of time. But if you do it, it will be very good. Or if you can't do it right now, then maybe in the evening, maybe in the tomorrow's before the start of the FDP session tomorrow, you can do it. Because once you do hands-on, then the things become settle in your mind. Yeah, okay, this is how we typically work like. So let's go rolling. This is briefly about me. I'm proud to be heading the Swinger Lab, Security Wireless IoT Network Group of Engineering and Research Lab. This is a lab which I have established in my university, and I have been fortunate enough to get good students from the BTech, MTech, MCA, and the PhD program, which we have just started. So these students have done very good work along with me, and I will just show you the. We have created a uh, uh, the site for our lab, and these are some of the students who have been working with me in this lab. Now, some of them are still working, some of them have joined the industry, and we have been able to carry out some good publication in the area of the security, in the case of the IoT, in the case of wireless network, and in the case of cloud computing. So it's all mixed. It depends, and some of them are even good in blockchain technology. So we have been fortunate enough to get good students and who have been able to do a good quality work. Since majority of the faculty members attending this FDP programs are teaching in the engineering colleges, so they can also have students along with them, because it's your experience, it's your knowledge base together with the energy of the students, which will help you to get some good working projects in the area of the IoT. So these are some of the publications we have carried out in the area of the Internet of Things, the IoT. The first were the, if you can look at, I hope the slides are visible and the voice is audible. A quick yes or no by anyone?
Sir, it's visible and
Fine.
voice
Yes,
is
sir.
Okay, sir.
audible.
It is
Great, great, great.
visible and
Yes,
voice
sir.
is also
It is
audible.
Great.
visible and
Thank you.
audible.
Thank you. So we carried out a publication on the basic concepts of the IoT called Concept Review and the Applications of the IoT, which we published last year in the IEEE International Conference. Then we've got another paper which we published this year. It's called Penetration Testing in the IoT Network. Now, penetration testing is another good area, emerging area in the area of information security. So we have got something called VAPT, Vulnerability Assessment and Penetration Testing. That's a keyword by which is very popular. So those of you who are working in the area of information security or intend to work in the area of information security is one of the exciting area where you can actually play with the network. You launch the attacks in the networks, any kind of the attacks, man in the middle attack, brute force attack, dictionary attack, modification attack, replay attack, masquerading attack, any kind of the attack. You showcase that the network is breachable, network is vulnerable, and you show the vulnerabilities of the network. So it's an art, and plus it requires a lot of proficiency. It requires a good amount of mathematics and algorithm and programming part to go for it. But it's a good area if you want to venture into the area of information security. penetration testing is good. So we have used a tool here called PMD, Programmable Mistake Detector, Programming Mistake Detector. So this is an open source Java based tool. I normally do all the stuff in open source, and that is what I always advise my students also, because then there are no proprietary issues, there are no licensing issues. Uh, you do not have to pay to anyone, to anybody, because funding is a big crunch in the area of the research. We are not able to get the good quality funding in spite of best of our abilities. So it's always preferred to work in the open source. That is what I normally do. You can also experiment the same thing with your students, because it's free from the clutches of the proprietary licensing. Then what we did last year onwards, we started working for Divyangajan. Now, this is a word which is being used by the government of India for the people with disabilities, what we call PWD. These are the specially challenged persons. So we thought, why not to use the IoT for the benefit of the special section of the society. So along with my students, we started working on it. So the second paper, which is TLC paper, traffic light crossing algorithm, in an IoT network of visually challenged person. This was the first paper we worked on, but this got published later on, and the IoT-based pedestrian navigation system for the visually challenged person, we got a chance to present this paper first. Though we started working on the second paper first, but this was first accepted, and we got an opportunity to present in the IIIT Delhi in the international workshop on AI for computational social system. Now, what was the objective of carrying out this work is, why not to do something for the benefit of person with disability. Now, PWD is a very broad theme, and there are many categories of the person with disability. A person can have a problem of the hand-eye coordination. He can have a problem in vision. Now, we are not using the word blind here. We are talking of visually challenged person. So, means the person is have a low vision blindness. There could be another category of person with disability, like the mental retardation could be there, a problem with the central nervous system of the body, uh, deaf and dumb. So there are various tracks on which we can take our research field for the benefit of the special section of the society. So I will also advise you that once your FDP is over, try to think about these tracks, because this is we are blessed by the God that we are all good, financially well off, blessed with knowledge. Then why can't we do something for this special section of the society? Now it requires a lot of passion, it requires a lot of energy, because you have to be self-motivated to do this thing. So, but we started this work, and again, I was fortunate to work with good students, and we worked as a team, and we designed the algorithm called TLC algorithm, which is now published in a paper, traffic light crossing algorithm, how a visually challenged person will be able to cross a traffic light in a city. That is what our proposed algorithm was. Then we designed a system called PNS, pedestrian navigation system, how a person will be able to walk on a city road, because nowadays we know city roads are all crammed up with the traffic. Now, how will a person who is suffering a disability will be able to walk? So we introduced a smart stick based concept. Though smart stick was already there, it was proposed by a professor from IIT Delhi. So we did not use the same word. We came up with our own concept. But yes, we use the same terminology, because the terminology is well accepted, but the style of working and the style of algorithm was different than what he proposed. Now this is another paper which has been now been communicated by us. It's called Astitva. It's assisted spatial tools and technologies for the inclusion of visually challenged person, which we have communicated in the conference to be held in December in IIIT Delhi in 2020. Now this is another special paper for visually challenged person, where we not only use the traffic light crossing algorithm proposed by us, we also use the smart stick, we also use the smart helmet. So let's say if a person is driving, not driving but cycling on a city road, now we provide him a smart helmet. Now helmet is very cheap, so we have tried to cut down the cost of it as good as possible. We could do that, though if we tie with some industry, then definitely can further cost can be cut down, or if we get certain funding, maybe another cost can be cut down. Now this helmet will be smart helmet. It can be controlled using a GPS navigation system, and because now all the maps of the cities are digital and they're all available. So we have fetched the map, stored into the libraries, and these fetch maps keeps on guiding the person that are there any obstacles Are there any pitfalls on the road? When to take left? When to take right? So the person can listen all this using the audio. We consider him as a visually challenged, the person who can see something but not completely see. So our system will help him guide on, will help him to move on the city roads as such. So we have started using IoT for this purpose now in the last 1 year or so. How we can try to help the person with disabilities. So let's see how far we can go and how our efforts can be beneficial to the special section of the society. Another research track which a lot of work is going on, and you can also venture into that. We have got a health informatics. A lot of work is being done, but see, you are doing some work, and let the other also do it. So it doesn't matter as such, because everyone's style of work is different. So if you do some, you propose some algorithms, you propose some simulation work, you do mathematics part of it, your work will definitely be different from the other work. As long as we do not get inspired and do some kind of the copy paste mechanism, which I don't think so. We do as a faculty members. Let's try to avoid as much that as possible. But then another track, agriculture. A lot of work is being done in the area of agriculture also. So we can pick up that. Even in the area of the disaster scenario, a lot of applications are getting coming up. So even if you can want to try explore that, then yes, because these are the areas in which if you're planning to do a PhD, or if you are in any stage of your PhD, and then if you write a research paper on these tracks, the possibility of acceptance of the papers is very, very high, because these are not routine mundane track. They have got some research opportunities with them. So finally the work that will come out of these your efforts, along with your student, if you're working with the BTech or the MTech students, or if you're working for your own PhD, then they will definitely be good, because all these tracks are very they have got a lot of opportunities to work on. So in the next 2 to 3 years, these tracks, the health informatics, uh, the agriculture land, the disaster scenarios, the field with especially challenged persons, they have a lot of opportunity which can be exploited to do work. And thereafter, what I visualize again, after 2 to 3 years, a lot of stalemate will come. Lot many publications will come out, lot many people will do the work, and then something new will emerge, because that's how the IT industry goes. Every area here survives for 3 to 4 years, and then again after that we have got something new to work on. So this is the right time if you want to work in the IoT area. There are many number of open source as well as proprietary simulators. Like I will show you the simulation about the MQTT. We'll also have a cup carbon simulator, which is again open source Java based simulator. You can download that and work in the area of the IoT for that. So even that is good work, where you can, because there are two tracks. Either you write the code on your own using Python or Kotlin or Java programming language, or you take some predefined simulator, and that simulator will provide you the basic backbone work, and then you can write your own top-up code on it, and then the things can start rolling out. So there can be only two tracks. Either you write your own code from the scratch, or you take any simulator. If I'm only talking the software track, and the hardware track, we all know Arduino, Raspberry, they are already there. But then if you want to do some research work, your code has to be generated. You have to show that what you have done, because then only the chances of getting a paper accepted in a conference or a journal becomes very high. So coming back to the core area of the IoT, so he is one of the pioneer figures, which I think some of the speaker might have also talked about, the Kevin Ashton, a British technology pioneer who co-founded the Auto ID Center at the MIT, which is the world best engineering institute, which all are familiar with, and that created a global standard system for RFID and the other sensors. And in 1989, he was the first person who coined the term as a IoT. So I always thought that before the start of the lecture, we should always pay tribute to him, that he was a person who was actually able to coin this word. And since then, many researchers around the world have been continuously working in the area of the Internet of Things. Now, if you look at this slide, many issues have been there in this slide. We'll talk of the business. We have got servers, we have got networks, we have got connection, we got people, we got applications, we got sensors, we got home, we got service, we got security. Now, IoT caters to a lot of variety of applications. So almost there is no area nowadays which is untouched by the Internet of Things. We talk of the things here. Things are the smart devices. That's what the word things here refer to, anything which is web-based, which has got the address, which could be IP address or a MAC address, along with the port number if we talk about the OSI model. So two things are required here. First of all, the thing here should be smart thing. Smart thing means it should be a thing which has got the network connectivity attached. So, and how will the thing come onto the network? Only if it has got the IP address and the MAC address. So these are the preliminary requirement we require in any of the devices which would like to become part of the web. Because once you become a part of the web, then now you can share the data on the scenario. And nowadays with the cloud also coming up to it, so now we've got the cloud-based IoT also. So we are merging that, rather not merging, but blending the benefits of both the two technologies, the cloud as well as the IoT. Also, another thing which I would like to share is a lot of work is getting done in the area of the AI, so artificial intelligence. So we can take the AI part in the IoT, and we can carry out the like Professor Vidyarthi would have talked about the machine learning part, if I correctly remember. So he's good in that. So you can take the benefits of the artificial intelligence and corroborate with the IoT to come out something good in the area of by blending the two technologies. So it's always advisable, it's always better that if you can bring out the benefits of the two technologies to come something new. So cloud with the IoT, or the artificial intelligence with the IoT, and in the IoT, in the artificial intelligence, you can either go track for the machine learning, or in the case of the deep learning. So that depends upon you and your taste and your area of interest, that how you can blend the two things to come up something good in the area of the IoT. Now, what my experience is, IoT is not always Internet of Things. It could be intranet of things also. For example, if I want to carry out a communication between the devices, just like what has been shown in this slide, here all the devices are in the single room or in the single lobby of a house. So I can have a refrigerator, a television, a microwave, a CCTV camera, doors, telephones, dustbins, anything. Any device which is smart, which has a sensor attached to it, it can talk to, it can communicate to another device which is the overlapping transmission range of each other. So if the two devices, it could be my smart doorbells or my refrigerators, they can talk to each other. The electrical chimney installed in the kitchen can talk to my refrigerator. My television can talk to a refrigerator. So it could be any number of the devices which are smart and which are web-based, which has got the IP address and the MAC address. They've got a sensors to sense the information around their environment, and they can coordinate and collaborate with the various devices within its overlapping transmission range. Because then that is how the seamless connectivity or seamless flow of the information will take place between the devices. So here we can see here the bulb is there, the electric chimney is there, even the fridge is there. It has got certain predefined tasks to do. So all of them are smart enough and they know the purpose for which they have been configured, and they will do the same job repeatedly n number of times with a same quality of perfection, because that is what the things are. So they work in the state of 0 and 1. Either the device might not work at all, or they will work with the same predefined task to the perfection without any problem as such. So if this is a scenario, then, and if I come to the concept of routing, now routing becomes a challenge because so many devices are flooding your lab area, your sample area. So you have to coordinate between these devices, how the one device has to be told to communicate with the other device, and it should not interfere with the other devices also. So routing in IoT is always a challenge, and that also throws opportunity and challenges for us, that how we can amicably do it. So as I said earlier, we have got two protocols for carrying out a communication. One is a MQTT, called as a message queuing telemetry transport, and the other is a COAP, or called the constraint application protocol. Both these protocols have slowly, gradually evolved over a period of time, and they are now established protocols by and large, with the help of which we can carry out the, I don't say the 100% effective communication, because that is virtually impossible in the IT world, anything 100%, but yes, a very good communication where the flow of the data or the flow of the information can seamlessly take place. Now, the MQTT follows a protocol model called the publisher subscriber model, called the pub sub model. Because if you look at the architecture, how they evolved over a period of time, initially we have got a client server architecture. We've got a physical device called server, and we've got many number of the clients, millions of clients connecting or hooking onto the server. Then slowly from the client server architecture, we migrated towards the n-tier client server computing, where it was said that a server will still be remain there and the client can be infinite any number of times between the any number of clients can be there which can connect to the server. But at the same point of time, between the client and the server, we'll have an additional layer called as a middleware or as a middle layer as such. Now this middle layer, which will have a collection of multiple number of business functions, and the code which we write within this business function was called as a business logic or the business rules. And this concept became very popular, the middleware computing, and slowly middleware computing gave further rise to the MVC architecture, the model, view, and the controller architecture, which is nowadays very popular, almost C#.NET and the Java and advanced Java, the J2E flavor, Java to Enterprise Edition flavor of the Java, works very fine on the MVC architecture as such. But IoT, what it started doing, it did not use any of these architecture. It came up with its own architecture, the publisher subscriber model, and built around the concept called the brokers. So we'll have a broker on between in the central core of the entire network, and we'll have the multiple number of publishers and subscribers which will be built around that particular broker. So I will share the slide how the diagram flows like. So we give the credit to Andy Snafford and Erlon Nipper. They were the person who actually visualized that we require a routing protocol for the IoT. And if you look around 20 years back, they came up with this protocol. So protocol was there in place, but not much work was done. It's only in the last 5 years that actual things have changed very fast, and lot many work was getting done using the Mosquito protocol or called the MQTT protocol. And therefore, for their work, they were also shortlisted for the ACM Turing Award, one of the widely popular award in the area of the computer science. So, we do not have a Nobel Prize in the area of computer science, right? Because we will not go into the reasons for that. The Nobel Prize is primarily awarded in the area of pure sciences like physics, chemistry, and biology, together with the Peace Award is also given in the Nobel Prize, and there are certain other categories. But the computer science is not a category in the Nobel Prize. So we do not have a Nobel Prize in the area of the computer science. What we do have is called the Turing Award, named after Alan Turing. We all know his contribution of the Alan Turing in computer science. He has done a lot, and almost every branch of science stands on the shoulders of few people. So Alan Turing is definitely one of those persons who can always be credited for his immense work in the area of the computer science. So in 1965, ACM, Association of Computing Machinery, started this Turing Award. And if you look from the 1965 to 2020, so roughly around 35 plus 20, 55 years have passed by. So considering the number of engineers we churn out every year, from the so many number of engineering colleges and universities of India, we should have been able to get at least 20-25 awards. But then somewhere our education system requires a churning, requires a revolution in terms of creativity, in terms of innovation, in terms of newness, that we should be able to think something new, what we call out-of-box thinking. And that is something I personally feel lacks. And it can also be seen from the Turing Award that out of in these 55 years, only one Indian has been able to get this Turing Award. And if our system would have been that good, we should have been able to get more awards. So this is a testimony of the same fact. And the person who got this award in 1994 in the area of artificial intelligence was Professor Raj Reddy. So that's a very sad scenario considering the populations, the computer engineers we have got, considering the India is number 1 and 2 in the software track, but still we have not been able to got this award, because every year the award is given for some breakthrough research for technological innovation in the area of the computer science and IT, and it's given to a person or a group of person who work in this area. So hopefully our new education policy will have more it will create more thinking minds. It will have much more technologically better students who can think out of the box and who can bring out certain newness, novelty, creativity, and innovation in our engineering field. And hopefully, in the next few years down the line, we will be able to get more of these awards, which has been a very bad what we see in the last 55 years. Only one of the award we have been able to get as an Indian. But they were also not able to get the award, unfortunately, but they were nominees. Even getting shortlisted for these awards is a pride, no doubt about that. Now let's come to the core part of the MQTT protocol. First thing first, it's a publish subscriber model driven. It's an extremely simple and lightweight messaging protocol because we cannot have a heavyweight protocol because our devices here are the smart devices. They are handheld devices, though some of them are fixed devices and some of them are mobile devices. So we need to design a protocol which should be very simple, lightweight, and consumes less amount of the resources. So that is what we said is designed for constant devices operating in a very low bandwidth, high latency, and even in the unreliable networks. For let us say I'm designing IoT network for a disaster area, city which has been suffered by the earthquake. I want to design an IoT network for that kind of application. Or I'm designing IoT network for a mountainous track. Now, those of you who have been to Char Dham Yatra, visited the Badrinath, Kedarnath area, you can see here, establishing a network in such a terrain is extremely challenging. First of all, it is not economically viable because you have to spend a lot of money to establish a network. Then secondly, not many users and consumers are there. So establishing a network in this kind of area is always a challenging. Or maybe I've been asked to set a network in the desert area, which is again a huge, extremely high temperatures running into 50 plus degrees Celsius, maybe in the Churu region in Rajasthan or maybe Thar Desert in Rajasthan. So all these networks establishment of all these networks in these challenging areas is very difficult because they're not economically viable. The fields is not conducive enough. Temperatures are running into extremes from extreme minus to very high positives. So it's very challenging to establish a network, but then the results are there because if life is all good, then where's the fun? You need to have some spunk, to have some challenges where you can actually showcase your own talent as well as abilities. So coming to the design principles of the MQTT, primary objective is to minimize the network bandwidth and device resource requirements. So just like any other protocol has some purpose, has some objective, same way MQTT protocol also has an objective, and primary objective is to make sure that our messages which get generated, they do not consume a lot of bandwidth from the network because already the networks are overloaded. So we should not introduce more protocols that put up more congestion into the network. And those of us who work in the area of network, there's a very popular saying, congestion breeds congestion. So if congestion is there, and if you don't deploy the algorithms to reduce the congestion, it will further increase it. And a time will come the entire network will get jammed up. So we should design protocols. It should have the design principle that they should not consume more of the network bandwidth. And at the same time, they should make an attempt to ensure high degree of reliability as well as high degree of the assurance of delivery of the messages. So messages, because if the message do not get delivered in one hop or they do not get delivered in one round trip time, the iteration time, then you will have to go for the retransmission. So again, you are going to overload the network. So objective should be that our protocol should be able to deliver the message right at one go with a minimum energy consumption and minimum consumption of the network bandwidth. So some more facts about the MQTT. MQTT has a client-server model where every sensor is a client and connect to a server known as broker over a TCP. Now here, the pub-sub model has been tried to map over to the client-server model. That is what the sentence says. Every sensor becomes a client here. And you connect to a server, and that server will not be a web-based server. It will be a server which we will call as a broker. So if I want to map my pub-sub model to a typical two-tier client-server model, or N-tier client server model, I say here sensor is a client and my server becomes a broker. Then again, MQTT or Mosquito is a message oriented, and every message is a discrete chunk of data. It's very opaque to the broker. And every message is published to an address known as a topic. So my broker will maintain a list of the topics. Now these topics can be the information about the atmospheric temperature, pressure, humidity, soil conditions, any kind of the sensing. So all this information will be kept by the brokers. And the clients, which we call here subscribers, can subscribe to one topic or it can be subscribed to multiple number of the topics. The topic will be listed with a broker, a single central entity called as a broker. And every client subscribed to a topic receives every message published to that particular topic. So if the client register himself as a subscriber with a broker and he pays certain amount of money to them, that I am the one, I am registering to you, and whenever you get the information, then you keep on sending a notification to me. So notification will keep on coming from the broker to that particular subscriber who has registered himself with a broker. So let us see about the architecture that will make the things much more clear. For example, a simple network is there with two clients called subscriber and one server called as a publisher. Along with that, we'll have a single central broker, and the broker will be entitled to maintain a list of the topics. Now, what are these topics? This will be a topic that carries information about the atmospheric temperature, pressure, humidity, soil conditions, means all those information which will be sensed by the sensor in the real-time scenario, where the IoT network will be established either in the lab condition or on the land conditions. And the client opens the Mosquito connections with the broker. Now here in the diagram, which is going to be the next slide, the client B and C subscribe for a particular topic with the broker. And by subscribing means you pay certain amount of the money, because here nothing comes with the free of cost. Otherwise, we'll have a difficult time establishing the IoT network. So cost is very nominal, it's very minimal, but yes, a subscription cost is there for the amount of the information you require from the broker. So this is how the broker model look like. We'll have a single central entity called broker, and then here we can see we have got three clients A, B, and C. Now they subscribe for a topic, and the topic here is the temperature. Let's say a subscriber would like to get the information what is the current temperature of the day, right? The maximum temperature and the minimum temperature that need to be specified. So here they become subscriber, both C and B, because they subscribe to a broker and then they say I would like to subscribe about the temperature. So they become the subscriber. And the client A becomes our publisher here. Now publisher has to publish some information to the broker, and then the broker will send the notification of that information to the registered subscribers. So if you can look at the arrow from the client C and B, it is towards the broker. That means they have registered themselves to the broker. And the client A is a publisher here. Client A sends the information from the real-time environment and publishes onto the broker. And the broker keeps on sending the notification of it to the multiple number of the subscribers. Now let's see how it typically works in the real-time scenario. Initially, we'll have a device, what we called as a broker, and which is now being configured and installed in the servers. So the many number of the servers which are there, like Pramati server is there, very popular server is there. Even IBM's servers have nowadays come. The Oracle servers have also now come. They all come with now a predefined loaded broker into them. So you pay a cost to them, and then they will provide you with the IoT services with them. So initially, we'll have got a single central server with a broker as a predefined process configured in it, right? And now we got another process called publisher. Now, publisher is something who will have a real-time deployment of the sensors in the land. For example, as a researcher or a funder, I have been asked to establish a network in the maybe in the mountainous tracts of Uttarakhand or maybe in the Rajasthan desert. So once you establish an IoT network, you need to have a hundred and thousand of sensors, because a single sensor will not need to do. So what I do is establish a broad network, maybe a 1 kilometer dimensions, uh, and I spread my sensors in this entire area, right? Now these sensors will start sensing the data. Could be the atmospheric temperature or a pressure or a humidity, soil condition. Because if I want to go for agriculture, I will need to have the information about the soil condition. So these sensors start capturing the information, right? So we need to capture the information and then we need to relay it. So I will establish a data center. Our data center will capture all this data from the flowing in from the sensors 24/7. So if I'm running my experiment for a duration of 30 days, so 24/7 for 30 days duration of time, I'm continuously sensing the data and I'm relaying it, or rather forwarding it to my data centers. Now data centers will have a publisher. Now publisher will keep on capturing the data and archiving it in the databases. Now we need to share this data. So there are two ways if I'm doing a research work. One is I establish my own IoT network and capture the data for 30 days. And then I look out for the people who are working in the area of IoT who would like to get the information of the temperature data of, let's say, Thar Desert in Rajasthan for a duration of 30 days. So those people will not themselves like to go to the desert region. So me as a researcher is doing it, and then what I do, I publish all this data onto the broker. A broker is a single centralized web-based entity. So here, and in the entire world, all those people who are working in the area of IoT and who would like to get the information that of the real-time data, they will go and register themselves with the broker. So moment I upload the data of 30 days for the June month onto the broker, so immediately the broker will send a notification to all those persons who are interested in getting the real-time data for 30 days. So they themselves do not have to go to that environment, and sitting in their own comfort labs, maybe in the UK or the US, they will start analyzing the data in the month of June in the India desert region of India. So, and that's a real, true data, authentic data. Because when you do the experiment, there can be two kinds of data. One is the artificial data, what we call synthetic data, which you create on your own within the lab condition, and the other data is the real-time data that which is actually fetched from the real-time test bed scenario, and then you carry out the experiments for it. So publisher is one who will bear the cost of setting the IoT network, and it will sense the information. There could be another example. Let us say I'm establishing IoT network in the Uttarakhand region, where we know terrain is very volatile. The mountainous terrain is not stable. There are frequent flash floods. There are landslides also, and the area is also vulnerable to earthquake. Now in this area, I would like to establish an IoT network, let's say 500 sensors. Now there could be a researcher working in the Cambridge University of UK who would like to know the soil conditions or the mountainous environment terrain of the Uttarakhand. So I am the person who go there, set up the network, gather all the information, archive all the information within the database, right? And then I need to now share the information. I need to earn revenue out of it. I need to earn money out of it. So I'm not, what I'm doing, I have already captured the data and now I publish it onto the broker. Now, all those persons around the world who are working in the area of IoT for this mountainous region, immediately they will get a notification that a new test data has come, or the new data set has been uploaded. And then they can download the data set after paying certain subscription costs towards the broker, which will also be paid towards the publisher. Now, that is one track where I'm sharing my data set. There could be another research track where I don't want to do this. I am the publisher, I am the subscriber, I am doing it for my own self. I do not share the data set with anyone as such. There could be multiple tracks how you would like to work on. So here, a broker maintains a list of the topics like temperature, pressure, we have just discussed, the soil conditions, if I'm doing it in a land environment, or if I'm working in the ocean seabeds, maybe the quality of the water in the ocean, which is going down nowadays because of the extreme water pollution, the fishes are dying down. So maybe my other experiment of the IoT could be working on the ocean seabeds, monitoring the flora and the fauna, or the aquatic life, quality of the aquatic life on the ocean. So it could be any of the topics. but the terrain has to be chosen. The application has to be selected that where you would like to work on. So a broker will maintain a list of the topic and will have a set of values corresponding to that particular topics. Now there could be a one subscriber or there could be 100 of subscribers who will go and then register themselves with the broker. So here we can see here subscriber 1 comes, subscriber 2 comes, and they register themselves with a broker that yes, they would like to have the information, the real-time information about what all is happening in the particular chosen IoT application. Now that application can be mountainous region-based application or a desert region-based application or the ocean seabed-based application, or it could be typical simple your home application. So any kind of the application can be there where the subscriber registers themselves with the broker. Now, one of the best way to understand this working of the pub/sub model is to look at the working of the property dealer in your colony or in your city. For example, if I am the owner of the house. Now, I would like to rent out my 1 BHK or 2 BHK, right? So what I normally do, I go and register my property with the broker. And I say, you now search for the tenant for me, right? So I will go and register, let's say, property on the first working day of the month, and then he will not charge me initially, but he will open a register there, and he will note down the information that whether it's a furnished accommodation, semi-furnished accommodation, unfurnished accommodation, 1 BHK or 2 BHK, have a PNG gas pipeline or not, have the parking space facility or not, food allowed is vegetarian or non-vegetarian. So all those features he will note down, that what all the owner has the features to offer in his 1 BHK or 2 BHK apartment. Now comes the second part, the tenant. Now suppose a new person has just moved into the city. Now he does not know anyone. So what he will do? He will go to the property dealer and he will say, this much is my budget, maybe 10,000 or 12,000 or 14,000 rupees, and I would like to have the 1 BHK or the 2 BHK. It should have a parking facility, it should not have a parking facility. So he will lay down his condition. Now what does this broker do? Broker will do the matchmaking types of situation. Let's say you got 10 properties listed here and you got 15 buyers and 15 tenants who are actually interested in rent. So he will do the best matchmaking, that the budget of the tenant and the facility he wants is available with a particular landlord or the owner of it. So here in our MQTT scenario also, broker is one who's a property dealer. The publisher is the one who's a landlord or the owner of the house, and the subscriber are the one who are the tenants. So maybe immediately property is available. So what will the property do? Tell the tenant that property what you are looking out, which suffice in your budget, is readily available for me. Then he will go and show that particular property. But if suppose a particular property is not available, then what will the property dealer tell the tenant, the prospective tenant, that you keep your phone number with me, you keep your email ID with me, we let you have your own information, and you can register yourself with me. As and when I get a property matching to your budget, I will immediately send a notification. I will immediately come in contact with you. So here broker also does the same task. Broker maintains a list of topics, and the topics are predefined, they are pre-subscribed, and the subscribers are all open, means they can always log into the broker and then register for a particular services. And let's say I have collected the data from the agricultural land for 30 days. Now a particular researcher comes and he says, I would like to have the data only for 7 days. So he will pay data only for the particular 7 days only. So from my data set, I fetch the data and I share the data only for the duration of the 7 days. So these are the data which are proprietary data set, and they're not free of cost or the open source data set. And the information, because now why it is proprietary? Because the IoT company or the IoT people, they are bearing a cost for setting up equipment, for setting up a data center, for purchasing and installing the sensors in the real-time conditions. And we all know sensors cannot live infinite. Sensors have got a very predefined shelf life. So we have to bear a cost, and the cost of the sensors can go anywhere from 500 rupees to 5 lakh of rupees. It all depend upon their precision, quality, configuration, accuracy of the data which they kind of the fetch on. So there are certain good companies. If you just Google on the, there are companies like in Delhi also a company is there. Then there is a company in Bangalore also. So I purchased few sensors as a part of my lab, and I have seen their contrasting results. So the good quality sensor will always fetch with accurate results. So whenever you're carrying out experiment with a real-time scenario, always make sure that we get a good quality sensor, so the data which you fetch is accurate and perfect. It should not have any flaws in it inside it. Because if the data captured is wrong, then everything after that, all the algorithm which you are going to deploy for the data processing will also have a fault inside that. So it's always better to purchase good quality sensors from the good company. So I don't want to name any company. There are many number of the companies who work in the area of the IoT. So if you're a faculty members working in the colleges, you can approach to this company. And if you get a good funding from any of your college or from the certain DST or DBT or MIT or any the CSIS or anyone who can be able to fund your project, then you can purchase a high good quality sensor because sensors are the first step towards a IoT network. Sensing of the information has to be good. We need to have the good quality of the actuators and the sensors. Otherwise, we'll have a flaw in capturing the data, and then the entire flaw will then have a ripple effect in the entire life cycle of the things. So nowadays, what the IoT is being done, IoT has become a part of the CPS, cyber physical systems, where we also bring a cloud as a part of the IoT. So maybe in the entire FDP, it might be there some talk or might has taken place or might take place in the future, where we will talk about the cyber physical system, where we will take the part of the IoT and merge it along with the cloud-based scenarios. So some of the typical facts and figures of the MQTT which we use in the programming. We have got three kind of the quality of service parameters, QoS. One is a fire and forget, which we number as a 0. Then we say delivered at least once, then we give the number as 1. And we say delivered exactly once, where we give the number as 2. Now if you look at the nomenclature, the word selection and all these QoS parameters, it's very clear. Fire and forget, typical scenario of UDP protocol in the network, that you broadcast the information and you do not worry that whether the information is reached to the destination or not. So just you fire the information as such. Delivered at least once means unless and until the acknowledgement comes from the destination, you keep on delivering, because if one ACK comes, that means you are assured that the packet has been successfully delivered to the destination. And exactly once means again it's a variation of the same from 1. When you set the value once, the multiple deliveries are possible, but in 2 will only generate a packet once and will deliver to the destination as such. So 0, 1 and 2, whether I go for a fire and forget means broadcasting. 1, yes, multiple messages might get delivered to the destination, but in 2, 1 and only 1 copy of the message is there on the network, which will get delivered from the source to the destination. Now there's an organization called IANA, Internet Assigned Number Authority. There's another organization called ICANN, Internet Corporation for Assigned Names and Numbers. So these are two very popular organizations that work in the area of the web-based environment, which I think many of you would have heard the name, both ICANN and the IANA. So IANA has reserved the port number for the MQTT protocol. It's called, port number is 1883. So it's a predefined port number for the mosquito protocol for the IoT. On the same lines, if I'm working in the area of information security and I bring the cryptography part also, means I write the code which involves certain cryptographic techniques like Caesar cipher or Veneer cipher or rail fence cipher or affine cipher or hill climbing cipher, or I'm using certain algorithms like DES, data encryption standard, or the RSA, Rivest-Shamir-Edelman algorithm, or the AES algorithm, then I need to transmit my data over the secure socket layer, because the safe and secured data cannot be transmitted over the insecure layer. So I need to use the SSL, secure socket layer. So IANA has reserved the port number 8883 for carrying out the safe and secure transmission of the data in the IoT network, and the port number 8883 can be used, which is a paid port, because security never comes free of cost. Somewhere somebody, maybe the source, maybe destination, or the middleware entity in the network, has to bear the cost for security, and the cost is nominal. It doesn't run into the dollars as such, very cheap cost, but then security comes at a cost. We never provide security as free, because there are again the reasons for it, so let's not get into that. But what we need to remember right now, port number 8883 is registered for mosquito protocol over the secure socket layer. Now there is a protocol called constant application protocol, what we call COAP protocol. So some prominent differences which I thought we should discuss. Mosquito uses a publisher subscriber model, whereas COAP has come on the request response paradigm. That's another very popular paradigm which works, which is a variation of the client server architecture that COAP uses. Another difference, Mosquito uses a central broker to dispatch messages coming from the publisher to the clients, whereas COAP is essentially one-to-one protocol and very similar to its working into the HTTP protocol, the hypertext transfer protocol, which works on the application layer of the OSI model and uses the port number 80. Another prominent difference, Mosquito is an event-oriented protocol, so there's an event-driven programming model which Mosquito uses, whereas COAP is more suitable for the state transfer. The state normally comes when you establish a session. So in a web-based scenario, we need to establish a session between the client and the server, and then we'll have a state for that particular session. So COAP is more suitable for the state management, whereas we say Mosquito is widely used for the event-driven architecture model. Now the work which I'm discussing here has been, we have published it as a part of the paper by the name Routing in IoT using Mosquito Protocol. It was presented in the 12th International Conference on Computational Intelligence and Communication Network, CICN 20, just a month back. The paper is now in the press, so probably in the month or so it will come online also. So all those papers which I have discussed here as a part of my presentations, they're all available on ResearchGate. So you can just drop a message to me and I will be happy to provide you the paper. So if you want to work in that area, or if you feel excited to work in that area, then I will provide you everything free of cost without any problem as such. You can just ping me, drop a message to me in the ResearchGate or on my mail ID rahul@ipu.ac.in, and I will be happy to share all this, any copy of the research paper. Now let's come to the simulation part. When we talk of the simulation, we'll use a broker here. So we say simulation using a Mosquito broker server, and there are two approaches for it. One is a predefined approach, and one is you write your own code, right? So the predefined code where you download the Mosquito toolkit from the web and configure it on your system and start using it. Another is you write your own self-written Java code where you write your own code using the predefined classes provided with the Mosquito protocol. So when we are using a predefined code, we need to follow certain steps because Java is very methodical in nature. It's very systematic programming language. So it follows certain steps that need to be configured on our systems and to actually work on. So first of all, we install the JDK, set the path of the JDK on our system. So normally it's always advisable that whenever you're working on the web servers or you're working on JDKs, we always set the path onto the program file. We stored the Java in the program file, the master drive of our C drive, the C drive. It's always advisable to store Java in the program file folder on the master drive. So we set the path of it. Then we install the Mosquito toolkit, which is a version 1.5.4, which I'm using it on my system. Then we set the location where to store it. It is again advisable you save the toolkit in the program files folder of your master drive, the C drive. Now, what do we do to start the server? We need to write a command. So we say mosquito.exe-v. Now v is a verbose mode, means whatever it will do, it will print the functionality of working onto the command prompt window. So let us replicate the same thing. I think that will become easy to work on and easy to understand. So I've already downloaded the Mosquito toolkit. I've already downloaded the JDK. I've already set the path of it. So what I do here, I start the Mosquito server. So what is the command I need to write? Just I showed in the PowerPoint slide. We say mosquito.exe-v. So I've created a folder called Mosquito, and the toolkit is a part of the Mosquito, and I start a server in it, right? So it's a Mosquito version 1.5.4 starting using a default configuration, opening IPv6 listen socket in port number 1883 and opening IPv4 listen socket in the port number 1883. So it has opened the port using both the IPv4, which is a 32-bit IP protocol, and the IPv6, which is a 128-bit IP protocol. So both the IoT network supports both the kind of the protocols, one for IPv4 addressing schemes as well as IPv6 addressing scheme, the 32-bit as well as 128-bit addressing schemes. Is this command prompt window visible on just a quick yes or no by anyone?
Sir, it's visible.
Okay, fine, great. So what I have done here till now, I have started the broker. That means in the IoT network, I have established one single centralized entity called as a broker. And right now, no publisher are there, no subscriber are there, right? Only we have got a single centralized entity called the broker. And now this broker has started, is opening up. So it is ready to receive the request. That is how we normally do in the web-based scenario also. We'll have a web server, and the web server opens up by opening a particular port. So normally in the typical web-based scenario, we open the port number 80. But here, for the IoT network, the Mosquito protocol, since we are using, the broker is receiving a request on the port number 1883. Now, that is what we have done here. Then what we do, we need to have subscriber now. Subscriber has to log in, because subscriber will say, okay, I would like to have certain information. So subscriber registration has to be done with a broker. So we need to type a command. So we say mosquito-sub.exe. Now this I'm using a predefined code, the way it has been provided by the Mosquito protocol to me. I have not written my own code for this particular program. It's a predefined code. I've just downloaded from the web a Mosquito toolkit version 1.5.4. Only preliminary requirement is what it wants is the JDK. So those of you who have got a JDK on your system, I will just share it so you can do the same thing on your machines also. So to start a server, I started a server, then I do a subscriber registration. So there's a predefined module for the subscriber. It's called module mosquito-subscriber.exe. It's an executable file. Now it is running on the local host, so I'm going to provide my own IP address 127.0.0.1, which is the loopback IP address for my system. Then T is a temperature. Then my MQTT is a my mosquito module, and within it the temperature. So this program provides a notification from the publisher to the subscriber regarding the temperature. So that's what the predefined task of this particular program is. So what I need to do, I need to open another command prompt window on my system, which will now simulate as a subscriber. One window is already opened up, that is simulating as a broker. Now I'm opening another window that will now simulate as a subscriber. So what do I do here? I have written the command that I will share the same thing on to you also, so that you can do it parallelly. So here I register my, if you look at the steps here, the first step which I have already written here, JDK installation, then installation of Mosquito, then setting up the path, then starting a server, and then what do I do here? I do a registration of the subscriber to the broker. This step number 5. So I open another command prompt window on my machine. Let me increase the font size so that it becomes visible. Now, if you look here, what I have done here, I have started a subscriber. Now this subscriber the cursor is continuously blinking. That means now subscriber is now registered with the broker, and it is waiting for the notification to come from the broker, right? So the cursor keeps on blinking. That means in the currently active state. Now what do? I open an other also, one more subscriber I open. Right, and so now at this point of time, what has been done, three command prompt window has been opened, simulating as three entities for the mosquito protocol. The very first one, we have got the information about the broker. Now if you see here, we started with mosquito.exe-v in the verbose mode. Initially it was giving information about only these three lines, right? The starting and then default configuration and then IPv4 and the IPv6. Thereafter, as and when I am opening more subscriber, the subscribers are getting registered. So new connection is getting established, new client is getting come, connection acknowledgement is being set, subscription is being done, but nowhere I have talked about publisher. So if you look at all the commands here, nowhere the publisher has come. It's only about the connection acknowledgements, sending, receiving, subscription, and the particular module is getting activated, the temperature module, and the information of subscriber gets displayed onto the broker window. So at this point, if you look at the subscriber window, it is waiting for the notification to come from the broker. Second subscriber, it is also waiting for a notification to come for the broker, because it is also pinging. It is also, the cursor is continuously bringing. Now I make an entry for the publisher. So what do I do here? I come to the desired window where I will set up my mosquito protocol so that it does not have a problem in starting up the things. And I increase the font size so that it becomes logically visible. Right? And now, if you look at the 5 steps have been successfully done. 6th step, I come check the connection status on the mosquito broker terminal, which we have just seen. Subscribers are now registered onto the broker window. Now the publisher comes, he sends a message to the mosquito broker, and then he quietly exits, right? So a topic is already decided. The subscriber has said that I would like to have the notification about the temperature. So temperature module has already got activated onto the broker window. So now in the 7th step, the mosquito comes, the publisher comes. So using the mosquito protocol, and it prints the information about 35 degrees Celsius, right? So we come to the last window, which is simulating as a publisher, and we say, if you look at the command prompt window, the mosquito publisher.exe-h localhost, which is currently active in my machine. In the real-time scenario, it will be the IP address of a particular broker on where the publisher is going to publish the message. But here, since it is my system, so it is referring to my machine, localhost. Then the temperature, my mosquito module, temperature, room, then the message, and it is 35 degrees Celsius. So we assume, and since it is a simulation, that publisher is going to print the information about temperature of 35 degrees Celsius onto the broker. So here publisher goes, and we can see here as the information come, it has still not come onto the broker window. As it come onto the subscriber, it has not come onto the subscriber window. So maybe it will take certain amount of time, the pre-processing time it will take to transmit the messages from publisher to the subscriber ID, but we need to keep them into the running state, because otherwise it will create a problem. So I'm sharing this steps onto chat window also, so that we can also, those of you who would like to replicate on your machine. So depending on your processing speed of the system and depending on the other information, it will take good amount of sweet time, and it will do it. but the steps has to be followed as it is, because they need to be done sequentially, otherwise things may not just work out. Now let's come to another part, where what we say that instead of using a predefined one, we would like to go for we would like to write our own code, right? Because not many things has to be done by our own, and they are not cannot become in a predefined pre-configured mode. So we need to write our own code. So this is what the code we need to write. So let me open it in a notepad so that the code becomes legibly much more clear and better to view. Yeah. So here what we have done initially, I will share the code. I will mail it to the Pawan sir, and then he will forward the code to you so that you can parallelly replicate on your own system. First of all, we need to import, because this is what Java is. First of all, you need to have the corresponding packages and classes in place before you start with the things. So here I'm using the Mosquito version 3 packages. So we say import. Now, Pahu is the name of the predefined client for the IoT network. Now, if you're using an Eclipse environment, you can directly import it here. But since I thought some of you might not be familiar with the Eclipse, so I copied the code and created a simple .java file where I can do it. Alternatively, you can download and configure the Eclipse on your machine, so that tomorrow we have got another session and we can discuss the same thing in an Eclipse IDE also. So what do we need to do? We need to download the jar files, because Java, that is what Java says. You need to have the libraries in place, and I cannot share the libraries onto the mail to you because they have to be downloaded and installed on your devices. But I will share the code where it becomes easy to code it. Then I import the scanner class. Then we write down the code. We say public class mosquito publish and the printing. So here in this program, this is the first phase of the program, wherein publisher comes and he prints the information, that is a message, onto the list of the topics associated with the broker. So we come to the line number 10 and we come to the main function. What this is how Java write the code: public static void main string and the args. Public we all know, so that the main function become accessible to anyone and everyone. Static in Java, at the main function, at this point of time we have not instantiated a class, so the object of the class is not available, is not accessible. So if the Java virtual machine need to make a call to the main function, it cannot do it. Why? Because the main function is encapsulated into the class. So what do we need to do? We need to main function as static, so that the function become independent of the object of a class. And now the accessibility is very wide. Now the JVM can directly make a call to the main function, because we have made the main function independent of the instance of a class. So we use the static keyword for it. Void is a return type, main is the name of the function. Now again, Java by default everything is of the string type. So whatever the other incoming parameters or the arguments, they're always of the args. They are received in args, but they always are of the type string. So string array and the args. Then in the line number 13 we come and we define the topic. So here we identify the topic as pressure. Now there are two ways. Either I can hard code this value of the pressure, or I can fetch it from the user that he prompts me to enter the value. So here let's say we prompt the user to enter the value. So we specify quality of service. So QoS parameter is specified as 1. Again, if you remember in the PowerPoint presentation, we've got a 3 QoS level: 0, 1 and 2. Fire and forget is for the 0, delivered at least once or exactly once. So 0, 1 and 2. So let's say we choose the intermediate level as 1. Then we specify the broker. So we use the local host running on the port number 1883. In the real time, it will not be the local host, but it will be the IP address of the broker window where the broker is configured. Now I specify the IP address for the publisher. So again, I make the publisher to work on my system. So I specify the IP address 127.0.0.1. Now we make a call to the one argument constructor of the memory persistence class, because we are going to use it. So rather no argument constructor, because we are not passing anything here. Now we come to the line number 20. Now in the line number 20, Java always advises that whenever you're working on the web, whenever you're doing a network programming, when you're doing a socket programming, when you're doing a database connectivity, when you're doing a file handling, it is always advisable that we write the code within the try catch. So the proper exception handling can be done, so that if at any point of time, if any problem arises, immediately exception can be thrown and it can be catch or it can be caught by the appropriate exception classes. So we write all the code for the IoT within the try block, and then within the catch, we have got certain predefined classes which are ready to handle the exception caught. So it could be like the get reason code, get message, get localized message, get cause, any kind of the exception class. So we'll have the matching mosquito exception class, which will handle the exception for us. Coming to the line number 21, what do we do initially? We make a call to the mosquito client constructor parameter as an argument. So we say mosquito client broker and we pass the information about the publisher ID. That's better. So we make a call to the 3 argument constructor of the mosquito client class, pass the information about the broker, which we have already passed here, pass the information publisher ID, and we pass the information about the persistent. Now persistent is saving the state of the object during the process of the transmission, so that whatever data is there, which is getting shared, because once the data is captured by the sensors, it will be communicated to the data centers and then forward to the relay to the further cloud-based web services, or to the actual for the processing of the algorithm, will forward the data to the lab conditions. So we need to make sure that the data remain in the persistent state. So Java provides the persistence property, and the Mosquito protocol provides it with the help of the memory persistence class. So we have already created a reference variable of the memory persistence. So we are using the same reference variable here as a third parameter of the Mosquito client. What we do next in the line number 22, we make a call to the no argument constructor of the Mosquito connection option class, because this is we are going to use in the subsequent line. So our reference variable is ready by the name connection options. So what do we do here in the line number 23? First of all, we set session clean. It is similar to something like what we use f/stdin in C and C++. So we clean the session. So this is a function available in the Mosquito connection option class, and by default the value is false. So we set it explicitly to true. Then the line number 24, we connect to a broker. So connecting to a broker. In line number 25, we set the connectivity activated. So sample client dot connect connectivity options, and if this line becomes successful, we'll display system.out.println and the connected. That means connection has got done from the publisher to the broker. Subscriber is not there in this picture right now. It's only one half of the things. How does the publisher get connected to a broker? Regarding subscriber, there's another extension of the same program, right? Now we prompt the user that now you input the value for the pressure. So we use a scanner classes for it. That's the way how Java works. A system.in is a standard input stream where the information comes via keyboard, and we prompt the person working in the lab condition on the when he's sensing the atmosphere temperature and pressure, that and you enter the value for the pressure. So SOP statement system.out.println enter the pressure. So we receive the value and store it into a string variable named as content. So here, let's say we have set up an IoT network in the mountainous region or in the desert region, and there we are fetching the value for the pressure. So the person operating on the land condition there, he inputs the value for the pressure. Now we display the same message once we receive it. So publishing a message, and the message gets printed on the line number 31. Because we have successfully received the message, we will print it. Now what we do, we need to print the message onto the broker. So what do? We need to fetch the byte from the string, because the printing or the transfer of the message gets done in the form of the bytes. It's a very simple way. How do we do it? We make a call to the one argument constructor of the Mosquito message class, and to this argument, what we do, we fetch the byte content from the content. Now here, the content is a string type variable, and we fetch the bytes from it. If everything is successful, within this message, we get the byte content, and then we set the quality of service. So it's a set QoS function. It belongs to the Mosquito message class, and we pass the value of QS. QS we have set the value as 1 in the line number 50, 15. Now in the line number 34, we publish the message to the particular topic. So topic was pressure, and the message has come and now get printed onto it. And if you're able to do it, we display the SOP statement, message published, and then we disconnect. It's always advisable that once the publisher has done the job, it should go and get disconnect itself, and then we display the SOP statement, system.out.println, and the disconnected. And then with writing system.exit, we close down the program and come out from the network. If there is any problem, we print the entire stack trace for the possible likely conditions that might arise in the execution of this program. So what do we do here? We compile the program and let's run it. So we compile the program. Let me increase the font size so it's much more visible to see if there is a problem in that. So the program which we have written, we compile the program and then we launch the program. So it is connected to the broker, localhost 1883. Let me close down the other broker window already running so that we do not have the multiple broker creating a problem on our system. Yeah. So let us start that broker once we have closed it down. So we start a broker. So it is now running, and now we come to our program for printing the value onto the, or the publisher will print the value onto the broker, right? So it says connecting to the broker on the port number 1883 connected. It asks us to enter the value for the pressure. So let us say we enter the value as 43. And then publishing a message 43, message published, and then it has got disconnected. So this is a part of the IoT network. We are using a Mosquito protocol. The publisher has printed the real-time value 43, the pressure value, onto the broker. And now we can go to the broker window and we can see that yes, the information has started coming in here. The client has got established, connected to it. Quality of service has been set. The new value of quality of service get activated, and though we have asked the value as 1, but it is still providing the quality of service as it will decide. So here MID value is 0, so it is printing using the value as 1, and we're using a pressure here, so printing the pressure, and the information about the previous module is also available here, the Mosquito module, the My Mosquito module for the temperature. So broker is logging a log file of the broker where all the information will keep on getting displayed. So that is all about from my side today regarding the Mosquito protocol. If there is any doubt, please feel free to discuss. I will be happy to handle the question.
So thank you, sir. Dear participant, please put your question on chat box, and I will repeat the question, and sir will answer that one. So please put your question if there is any question or any doubt regarding this.
So I hope everything is clear.
Uh,
That's great.
I think everything is clear, sir. If anybody want to interact directly, then you can unmute. Please unmute yourself.
I've tried to share the code on the chat box also, but I don't think so the entire code will come because of the limit in the size, the number of posts a person can make. But I will post the program to Pavan sir so that he can forward it to your mail IDs. So they can
Yes,
replicate
sir.
the
Yes,
same
sir.
thing on your systems also.
Actually, this lecture is also being recorded and will be put it
Okay, that's
publicly
great.
in
That's
on the ICT website also.
yeah,
And by the evening, I will share the link of this video, recorded video,
sure,
and
sure,
the
sure.
PPT and whatever code you want to share, you will send. I will share with the participants.
Yeah, yeah.
And most important is that sir will take two more lectures, and he will elaborate the things I have requested him, and he has given his kind consent in this because he has such a good lab, Singer lab, and so I have requested him so that you can get the real practical applications of IoT, and uh, you can get a good experience of theoretical and practical knowledge. And thank you, sir, for your consent and giving your valuable time
Welcome,
out of your.
Pavanji. Welcome. My pleasure. My pleasure.
So, thanks. Now, dear participant, now this session is over, and we will meet tomorrow at the scheduled time. So, hope it is tomorrow. It is started from 10 a.m. So, thank
Okay.
you, sir. Thank you. Now you
Welcome.
can.
Thank you all for listening to the lecture so patiently. Thank you all.